Hello everyone, welcome to the third part of motion and time chapter. Today we will cover some basic fundamental questions on motion and time. It will certainly help kids to understand this chapter in a better way. So as quantity of question is slightly more, so we have used pen and paper. So I think it will be helpful if you read the question properly and try to solve yourself, and then in case of doubt you can see my explanation also. The first question, match the following. So column A some parameters are there, column 2 some parameters are there. So distance, scalar, vector, and D shortest path between the 2 points of motion. So distance will be the actual path traveled. So A is equal to, A will match with 4. Scalar, scalar is the speed is the scalar quantity. Vector, velocity is vector, and shortest path between 2 points of motion, that we already explained it. It is displacement. So hence correct option is B. A4, B3, C2 and D1. Now come to the next question. Again match the following, column A and column B. Option A, B, C and D in column A. A body falling freely, distance with direction, a speed with direction, rate of change of velocity. So this type of question you match the easiest one, which your mind catches first. The rate of change of velocity is acceleration. You match this. Then free falling body में acceleration uniform होता है. You can put this. Then distance with direction. If something is distance with direction, then it will be known as displacement. A speed with direction. A speed is a scalar quantity, but a speed with direction will become a vector quantity. It will become velocity. So correct option is A. Understand? See, this very small questions, but it will really help you to understand this chapter better, and your fundamental will be strong. Next question: if a simple pendulum takes 36 seconds to perform 10 oscillations, then time taken by it to move from one extreme position to the mean position. Option is there in the next page, but try to solve it here. What it is telling? Simple pendulum what is the time period of a pendulum? If it is starting from here, it is going there, then again coming here, going to this extreme position, again coming back here, then one cycle is considered to be completed, and time taken to complete one cycle is known as time period T. So here it is taking 36 seconds to perform 10 oscillations. Means for one oscillations it will take 36 by 10 is equal to 3.6 seconds. The question is how much time it will take. The question is from one extreme position to the mean position, means from here to here, means 1/4 of total time period. The time period is divided into 4 parts. One from here to here, second from extreme to mid, third mid to again extreme, and fourth part from another extreme to the mid. So in these questions, the answer will be 1/4 of the time period, that is 0.9 seconds. Hope you understood this. So answer is C, 0.9 seconds. Now come to the next question. A bike rider applies brake and brings the velocity of the bike from 80 meters per second to halt in 20 seconds. So They are asking the acceleration of the bike in meter per second square. To solve this type of question, you just write what is given. Initial velocity is 80 kilometer per second. Time taken is 20 seconds. In this 20 seconds, the velocity becomes 0. Final velocity becomes 0. Because bike comes to the halt. Halt means 0. Then you use the formula V is equal to U plus AT. Now V is equal to 0. U is equal to 80 plus A. 20 second is the time. Bring 80 to this side of equal to, it will become minus 80, A into 20. And A is equal to minus 80 by 20. It is minus 4 meter per second square. So answer is A. Now the next question is slightly tricky for the kids, as it does not involve any calculation, just you have to understand the concept. The question is, distance time graph has been shown and 3 graphs are there, A, B and C. They are asking if SA, SB and SC are the speed of the car A, B and C respectively, then choose the correct answer. SA means which car speed will be greater. The question is asking that. So you just see the graphs and try to understand what it is showing. This side y-axis distance is there, x-axis time is there. And suppose some car A is taking 100 seconds to cover some distance. Distance for all the car is same. For covering the same distance, car B is taking 200 seconds. Again, for the same distance, car C is taking 300 seconds. Now I think you might have understood the answer. The speed of the which car will be maximum. Obviously, the car which is taking minimum time to cover the same distance will move faster, and hence the speed of a car A will be greater than the speed of car B, and the speed of car B will be greater than the speed of car C. Option number A is the right answer. So if you will solve this type of graphical questions, it will certainly help you to understand some difficult questions later way. Okay. Now question number 6 to 10, one table is given. I think from 6 to 10 the questions will be given from this table. So you just see the question number 6 to 10. A bus moves at uniform speed v1 for some time and then with uniform speed v2. The distance time data table of the motion of the bus is given below. So you just make a graph for this. Time in minute and distance in kilometer. Okay, so you see the range of the time 20 to 120. So you just take 20, 20, 20, 20, 20, 20, 20, 40, 60, 80, 100, 120. Time is distance range is from 0 to 155. and you also take it in the form of 20, 40, 60, 80, 100, 120, 140, 160. This is 160. 20, 40, 60, 80, 20, 40, 60, 80, 100, 120, 140. If you will observe the table, you can make a graph also from here. 0 time में 0 distance, 20 minute में distance is 20, 40 minute में distance is 40, 60 minutes में distance is 65, somewhere in between 80 and 60. So up to here the speed is uniform. If you will write, make the graph on a scale, it will come a straight line. So a speed is uniform till 40 seconds, and I think this is the velocity v1. Question is given that one part of the distance the bus is moving with uniform velocity speed v1 and then uniform speed v2, and from here to the 120 second, if again you can make pro 80 second 95, 60 you already made 65, 80 में 95, 100 second में 125, and 120 155. Now we will see the questions. The value v1 is, they're asking the value v1. See, 20 minutes 20 kilometer, 40 minutes 40 kilometer. So distance by time is the speed, v1 is equal to distance by time. So first 20 second we will consider, 20 minute, then it moves 20 kilometer by 20 minute, so 20 by 60 hours. 20 already deducted, and this 60 will come upside, so answer is 60 kilometer per hour. You can understand it from graph also. If somebody is moving, some car or bus, anybody is moving from 20 minutes 20 kilometer, 40 minutes 40 kilometer, it means with the same speed it will cover 60 kilometer in 60 minutes. So 60 minutes is 1 hour. 1 hour is in 60 kilometer in 1 hour. So speed obviously will be 60 kilometer per hour. So 6 number answer is A. 7. The value of V2 is, again with the same trick you can see, table up to 40 it was moving with uniform velocity speed. 60 to 120 time taken is how much? 60 minutes. Time taken is 60 minutes. Distance traveled is 155 minus 65. 155 minus 65. Distance coverage 165 minus 65 is equal to 90. So 90 kilometer in this question, 90 kilometer traveled in 60 minutes means 1 hour. In 1 hour, how much the car or bus is moving, that is known as the speed. So 90 kilometer per hour. Third, what is the distance covered by bus in the first hour? First hour you can see the graph or table both. First hour means 0 to 60 minutes. So it travels 65 kilometer. Answer is 65 kilometer. What is the distance traveled by the bus in second hour? Again, second hour means after 60 to 120. So total distance traveled 155 in first hour 65. So you minus 65 in 155. The answer will be 90. In second hour bus travel 90 kilometers. So answer ninth answer is B. Sorry, A, 90 kilometer. Now 10. What is the average speed of bus for complete journey? See, average speed, whenever you are encountering this type of question, average speed, just remember one thing. Average speed is equal to total distance traveled divided by total time taken. Total distance is 165. In table also you can say total distance traveled is 165 and it took time 2 hours 120 minutes. So 165 kilometer 120 hour means 20 minutes means 2 hours. So the average speed will come 77.5 kilometer per hour. So 10th answer is D. Okay. Move to the next question. Again, the question is on pendulum. A simple pendulum takes 6 seconds to complete 3 to and fro motions. Means again you make this simple pendulum 3 to and fro motion. 3 to 1 fro means from mid position to one extreme, then one extreme to the mid to another extreme, and another extreme to mid. This will be known as one cycle, 1, 2 and 3 rotations, 2 and 4 rotations. So similarly, the pendulum is taking 6 seconds to complete 3 types of this to and fro motions. 3 types of this to and fro motions. Question is the time taken by the bob. Bob means the things hanging on the ball type of thing hanging on the pendulum. The question is the time taken by the bob to move from one extreme position to another extreme position. Means it is asking the time from here to here. See, this is divided in 4 parts. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All are equal. So they are asking the half of the time period. So it is taking 6 seconds for 3 oscillations, you can say 3 and 2 and fro motions. For one oscillations, it is taking 6 by 3 is equal to 2 seconds. So time period is nothing but time taken to complete one oscillation, that is 2 seconds. Here it is asking the time from one extreme position to another extreme position, that will be time period divided by 2. It means 2 by 2 is equal to 1 second. Again understand, in case of simple pendulum, the time period is the time by which the bob of a pendulum moves from center position to the one extreme position, again from one extreme position to the mid position, then from mid position to another extreme position, and then again another extreme position to the mid position. Means from where he has started, it will come again there after touching both extreme position, here, 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 then here, 1. So it is asking the time taken from this to this, means half of the time period. That is why the answer is 2 by 2, means 1 second. I hope it is clear. Now next, A car starts from Chennai at 6 am and reaches Warangal at 9 am. If odometer reading shows 9150 km at Chennai and 9300 km at Warangal, then the average speed of the car is. See, first note down the time. How much car has traveled from 6 am to 9 am? It took 3 hours. Odometer is the instrument in car which shows the distance moved by a car. When the car started from Chennai, the reading was showing 9150, and when it reaches Warangal, the reading was 9300. So distance traveled is 9300 minus 9150. It means 150 kilometer. Hence, average speed is total distance traveled divided by total time taken is equal to 150 kilometer divided by 3 hours means 50 kilometer per hour answer. Okay. Now next, a stone dropped from top of a tower. If it reaches the ground in 5 seconds with a velocity of 50 meters per second, the acceleration of the stone is. Question number 13. See, without if you don't have time, then it will fall with the acceleration due to gravity, that is equivalent to 10 meters per second square. You can just write the answer simply 10 meters per second square. But this is a numerical, maybe data value is not like that it will come 10 meters per second. So calculate it. So use formula V is equal to U plus AT. In this question, the stone dropped from a tower. When the stone was getting dropped, its initial velocity was 0. When it reaches ground, its velocity is given 50 meters per second. It takes 5 seconds. So you put all these things in that formula. So V is 50 meters per second. U is equal to 0. A and T is equal to 5 seconds. 50 meter per second is equal to 0, you neglect 5a, here answer is in second. You even don't want to write the units, no issue, and later on just write the unit along with the answer. So a is equal to 50 divided by 5 is equal to 10 meter per second square. This is also the value of G approximately in round figure, acceleration due to gravity. So this is the way you can solve. Another very tricky question is there. A graph is drawn between the displacement and time taken for the oscillations of a simple pendulum. Why it is shown like this? Suppose, like I have already explained, in case of pendulum, from 0 position it is moving up one side, then it is again coming to the same position, then it is going to the extreme position, then it is coming back to its initial position. So if you will show it in distance time graph, so displacement time graph, it is starting from 0 going to one extreme, then again coming to the next position, initial position means mid position, going to the another extreme position, then again coming to its initial position. So after starting the motion from here, it complete one oscillation from here up to here, like from here to here, then again here, again there, and 4 part. 1, 2, 3, 4. 1, 2, 3, 4. So while completing one oscillations, it takes 2 seconds. It is written T is equal to 2 seconds. time period. Graph you have understood. Time period you have noted. Now see what is the question. The length of the pendulum A we have to find in meter, and they are telling to take G is equal to 5 meter per second square and pi square is equal to 10. For this you have to note down one formula. T is equal to 2 pi square root L by G. This L is nothing but the length of the pendulum, G is acceleration due to gravity, and pi is a constant, T is a time period. Time period we have already found that from one cycle it takes 2 seconds, so its time period is 2 is equal to 2 pi under root L by G. 2 you bring to this side, 2 by 2 is equal to pi square is 10 given. See, pi square is equal to 10. So pi is equal to, you can write root 10. Okay. So root 10. Here you can break the square root of L by G in two parts. A square root L divided by a square root G, and G value has been given 10. So this root 10, this root 10 cancel, this 2 cancel. So answer will 1 is equal to root L, hence L is equal to 1 square. What we did, we have a square both sides. So this a square and a square root cancelled, 1 square is nothing but 1. Hence length of the pendulum L is equal to 1 meter. So with this we have completed 15 questions, and I think some very fundamental questions for the kids. And if you are covering this so many questions in any chapter of the physics, basically that chapter you will be very good. Your concept will be very good. Now some true and false questions are there. We will see this. Question number 1 to 12. Some true false questions are there. Statics and dynamics are different branches of mechanics. This is correct. Statics deals with the motion and all, while dynamics deals with the motions considering the force also. This is true. A branch, in later classes you will know in details what is the exact difference between statics and dynamics. A branch that deals with motion of a body without considering the causes of the motion is called statics, while in dynamics the causes of the motion will be studied. Again, what is there? A branch that deals with the motion of the body without considering the causes of the motion is called, no, it's false. Now an arrowhead is used to represent the scalar quantities. False. Arrowhead is used to represent vector quantities. It shows direction, so it is false. The length of the line in geometrical representation of a vector signify the magnitude of the vector. Later class also you will understand this slightly more with more clarity. The magnitude of the length, if you are representing vector, no, suppose somebody is moving from A to B and B to C like this, then its shortest distance is AC. So the length of this is magnitude, while the direction AC, the length of the AC is magnitude, and direction will be given in which direction it is there. To represent vector, both magnitude and direction is required, while length of the geometrical representation will give the magnitude of the vector quantity. So fourth is true. Fifth, a body first displaced by 5 meter and then by 12 meter in different direction. The minimum displacement it can have is 7. It's true. Understand why it is true. This question is telling a body starts and moves 5 meter in one direction, then in different direction it moves 12 meters. So while coming it will come 5 and then it has to cover 7 meter additional to complete 12 meter in reverse direction. So 5 already covered and it came to the initial position from where it started. So now its displacement, or you can say the straight line, if it is moving, the distance is 7 meter from where it has started but in reverse direction. So displacement is nothing but 7 meter. Uniform speed is a vector quantity. Wrong. A speed has only magnitude, it does not have direction. So a speed, even if it is uniform, it cannot be a vector quantity. 6. Question number 7. For a body moving along a circular path, the average velocity and average speed can never be equal. See, this question is very good. Suppose something is moving in circular path and with uniform speed. For one revolution, it is taking 1 hour. From starting from here, then we can say it that the speed is uniform. But vector velocity is a vector quantity for every moment. If suppose it is here, then direction is here. If it is body is here, direction is here. 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 So at each and every moment, speed may be the same, but direction is different, and velocity is combining the magnitude and direction. So at every point, velocity is different. So we can say that average velocity and average speed can never be equal, never, no, even a single place. So this statement is completely true. 8. A body can have constant speed and still have varying velocity. Yes, the same example. Body is moving uniformly, taking 1 revolutions, 1 hour for 1 revolution, so speed is uniform. But velocity is varying every point, each point, because velocity is having magnitude and direction also. So this question is also true. This statement is also true. 9. The magnitude of average velocity is always equal to the average speed. Magnitude, if it is coming, and see, suppose some body started from here, it gone there, then again came back to here. Displacement is 0 because from where it has started came to the same point, so displacement is 0. Time taken, suppose 1 hour. So average speed and average velocity will be all 0 because 0 by time taken, but distance it has covered, suppose from here to 2 kilometers to 4 kilometers, average speed will never be 0. So the question again you read, the magnitude of average velocity is always equal to average speed is completely false, because in that case, in this example, average velocity is 0 but average speed cannot be 0, both magnitude are different. Okay. 10. Velocity time graph cannot be used to find instantaneous velocity. Obviously we can use it for instantaneous velocity. Instantaneous means like a car. At what time, at momentum of time, what is the speed? So with the time velocity graph we can find at what time what is speed is there. This is false, we can find. 11. The average velocity can be calculated by taking the average of initial and final velocities of a given time irrespective of type of acceleration. Completely false. In the very first part I have told that average velocity we can find like total displacement divided by total time. Also we can use initial velocity plus final velocity by 2, but it is the case when acceleration is constant. Suppose you are riding a car and moving with uniform acceleration and started with 0 velocity, and after some time you reach some velocity v. then your average velocity you can say that u plus v by 2. But if you are riding a car and sometimes you are increasing its speed, sometimes decreasing its speed, sometimes accelerating, sometimes decelerating, so you have initial velocity because you have started from zero, but you don't have one single final velocity v. In between so many velocities you have, so which final velocity you will take to use this formula? So this formula can be used only when acceleration is constant. Understand? Okay. Now 12th. The travel of a train from one station to another station is an example of translatory motion. Okay, you can consider it because railway track is a straight line. Translatory motion means body moving from here and going there in a straight path. You can consider it true. Now 13 to 19. Fill in the blanks. An aeroplane is moving with uniform velocity of 80 km per hour, then the instantaneous velocity will be equal to the average velocity. Uniform velocity, if something is moving with uniform velocity, means what is the speed here? The speed will be same here, speed is same here. Every moment speed is same. If everywhere, every moment, each moment the speed is same, so instantaneous velocity is equal to the average velocity. No doubt in that. Hence, its acceleration is zero. Acceleration is change in velocity with respect to time. Within a certain time interval, how much velocity has been changed. Velocity same here, same here. Suppose some interval time is there. So the difference in velocity is zero, hence acceleration is zero. Understand? 14. The ratio of total displacement of a body to time taken is average velocity. That is what we are always discussing. The total distance by time is average speed, while total displacement by time is average velocity. Now, next question. The velocity time graph of a body moving with uniform velocity is a straight line parallel to. Now you see. Understand it in a better way to improve your concept. They are telling velocity time graph. And body is moving with uniform velocity, means with respect to time is increasing, its velocity is not increasing. Suppose it is at some certain velocity v is equal to 10 km, any xy km per hour, and with time velocity is not increasing. It means the graph is parallel to the x-axis or parallel to the time axis, you can say. Okay. 15h over 16. A body moving with in constant speed has zero acceleration only when the particle is in one dimension motion. Why? They are asking the speed and zero acceleration. If it has more than one dimension some motion, like circular motions, or like it is going from here then here, even if it is uniform velocity, uniform acceleration from here to here, here to there, its acceleration cannot be zero, because that after changing its motion, velocity changes, then obviously this it should not change its direction. In simple way you can say, when it will not change its direction, when the motion of the particle will be one dimension. Okay, because a scalar is only having magnitude, while vector has magnitude as well as direction. Question number 17. The average speed of a bus in its whole journey when it travels a given distance between two places with a speed of 20 km per hour and returns back with a speed of 12 km per hour each. This is very nice question. Most of the student makes mistake in that. What they are doing, 20 plus 12, 32 by doing 20 plus 12 by 2. They will simply write 32 by 2, 16 kilometer per hour. That is a wrong answer. Why it is a wrong answer? Because you always use this formula only while calculating the average speed. Average speed is equal to total distance divided by total time traveled, time taken. Question is the average speed of a bus in its whole journey when it travels a given distance between two places with a speed of 20 km per hour and returns back with a speed of 12 km per hour. Suppose the bus travels from A to B. Distance between A to B is x. Then while going, it took time distance x, and that distance, suppose this distance is to x kilometer, and it travels with 20 kilometer per hour. So time taken is this. While returning time, suppose this time is t1. Returning time, it is time taken will be, distance is again same x, while a speed is 12 km per hour. Kilometer cancel, answer will come in hour. T1 is equal to x by 20 hour. Here time is equal to x by 12 hour. Total time taken T1 plus T2 is equal to x by 20 plus x by 12 hour. Total distance we know, x while going, x while returning. So average speed is equal to total distance by total time, x by 20 plus x by 12. Now 2x, 20, 12 LCM. LCM you can find in two ways. You read the table of 20 and 12, wherever it will match first, 20, 40, 60, 12, 24, 36, 48, 60. First time 60, 60 is matching, 20 and 40 is not here in this table. Okay, so in a simple way you can say that the LCM is 60. 23 is 3x, 12, 5 is 60, so here 5x. This 60 will come. Now average speed is equal to 2x divided by 5 and 3, 8x into this 60 can upside, xx 2 4 ja. So average speed is equal to 60 divided by 4 is equal to 15 km per hour. While most of the student will do 20 plus 12 by 2 is equal to 32 by 2 is equal to 16 km per hour, and your answer will be incorrect. You will lose 1 marks if the marks of the question is 1. So what I mean to say is always every time keep it in mind that while calculating average speed, you must use average speed is equal to total distance traveled divided by total time taken. Separately I have calculated the time t1, t2, total distance, divided it, solved it, the correct answer came. Okay, now come to the next. When a particle, 90 number question, when a particle moves in a straight line from a point A to point B, the distance covered is equal to the magnitude of the displacement. Here what will be in the fill in the blanks, equal to, because maybe displacement is 0. If I started from A, gone to B, again came to here, so displacement is 0, but magnitude of the displacement is there because the direction is involved in vector quantity, so its final answer is 0, but magnitude is this equal to the distance covered. So I think this also covered. So some more portions are there. See, some question number 1 to 10 will slightly cover it faster. Some options are there, a statement 1, a statement 2, and we need to find the correct answer. The question number 1, the distance measured upward from the point of projection is taken as negative. The distance measured downward from the point of projection is taken as negative. A statement 1 is correct, a statement 2 is false. Then come to the next question. A statement 1 is a particle moving along a straight line and does not retrace the path. Moving in a straight line and does not retrace the path. It is not coming back here, moving. Second statement is a particle moves with uniform velocity. Uniform velocity. What is the velocity here? Everywhere velocity is the same. Both the statement 1 and the statement 2 are correct, and the statement 2 is in the correct explanation of A. Okay, because a particle moving along a straight line and does not retrace its path, a particle moves with uniform velocity. Okay, this statement 1 is correct. Now this is the third one, is slightly tricky, means you have to understand the graph. A body describes uniform accelerated motion along a straight line. Which of the following displacement time graph represents the uniform velocity? The Vt, if you are drawing the graph V and T, velocity and time, then it will come a straight line, because at equal interval of time, equal increase in velocity is there. So it shows acceleration is constant. But this is not V time. They are asking displacement time graph. So it will come like this. You can understand it in better way. S is equal to ut plus half at square. This is the formula. Distance and time graph. This representation is this. S is equal to ut plus half at square. Means one parameter is S and another parameter is T. The relation is S is, you can say, is proportional to T square if you neglect this T. So if it is distance is increasing, time is increasing double, distance is increasing half. You can understand in taking some example. 1, 2, 3, 4 second, 0 T distance S. So you forget about ut, just u2 square you calculate. If it is 1, it will be 1. If it is 2, then 2 2 ja 2, 3, it is 4. If it is 3, then it will be 5, 6, 7, 8, 9. So 1, 1, 2, 4, 3, it will become 9. So how it will go? Like this. Okay. For explanation purpose, I have used this type of example. So the correct answer will be here 1 only. 3, 1. 1. Option is 1. Now, fourth number question. A stone is thrown horizontally, means, and follows x, y, z. Suppose roof is here. You can consider. When a stone is thrown, it is following the path x, y, and finally come to the ground G. The direction of the acceleration of the stone. Direction of the acceleration will be always negative, and that will be the acceleration due to gravity. So answer A is correct. Fifth number question. A fighter plane moving with certain speed towards east. Towards east. East, west, north. No, your right hand side will be east. Your left hand side west. This north. This south. Always remember this direction. Even in India map, you can just simply I draw. You know, Himalaya is there in the north, South Kanyakumari in the south, Gujarat in the west, and Bay of Bengal, Purvi Bengal, and all in east. So direction you will remember like this. So aeroplane is moving in the east direction, takes 90-degree turns and moves towards north. 90-degree turns and moves towards north. First it is moving towards east, then towards north. With the same speed, which of the following statement is not correct? I will directly go to the right statement which is not correct. The average velocity of the fighter plane is 0. The 0 speed will come when it is coming to the initial position, then displacement will be 0, and then average velocity will be 0. If it is turning 90-degree turn, its displacement is there, some displacement is there, displacement is not 0, and obviously it might have taken some time to travel from here to here and from then here to there. Okay, so some time and some magnitude is also there for the displacement, so average velocity will never be 0. Only in one case it will be 0, if the aeroplane would have came to the same point from where it has started. So option number D is the correct answer. Then assertion region question is there. A metallic wire fixed at its ends when plugged executing periodic motion. Suppose some wire plugged at both end and you have disturbed it, plugged it and left it, then it will be vibrating. So truly it will execute periodic motion. Periodic motion is a motion that represents itself at regular interval of time, like pendulum case you have seen. So it is repeating after some time like vibrating wire. So I think both the true and R is the correct explanation of A. Sixth option A. 5-10 more questions are there. Again, assertion regions. On increasing the length of a simple pendulum, the time period of a simple pendulum increases. We have already used this formula, T is equal to 2 pi square root Lyg. If length increases, time period will increase. Statement 1 is true. Time period T of a simple pendulum is directly proportional to the square root of the length of the pendulum. Okay, both are true and second is the correct explanation of A. Now 8, matching, column A, column B. Guitar, string, speedometer, odometer, rate of change in velocity. Rate of change in velocity, you just put acceleration. Then guitar string, vibratory motion. Odometer, distance moved. Then remaining one, rate of change in velocity, acceleration, you have already done. Odometer, speedometer remain kilometer per hour. Telling a speed, so correct answer is C. Now 9th number question. Which of the following steps in correct order to determine the frequency of a simple pendulum of length L? You need to find the frequency of a time pendulum. And what you will do? They are explaining the process, but you need to arrange it in sequence, A, B, C, D, like that. So let the time period of a simple pendulum be T. Use this formula, T is equal to 2 pi root under square root Lyg. Determine the length L of the simple pendulum from the given data. The frequency N is equal to 1 by T Hertz. So this D will be certainly in the last step. First, what you will do, you will find the length L, C. Then you will put the T and find the A, C, A. Then B, D, like this, C, A, B, D. Answer will be C, A, B, D. Understood? They are asking the steps. What you will do first, determine the length L of the simple pendulum from the given data. You will first find the L. First process is C.